So now the integral that we're going to do is over the region 0, 2 cross 0, 2. But we want it below the curve xy is less than or equal to 1. So let's go to Desmos to see what this looks like. So the green square, this is the square 0, 2 crossed with 0, 1. And then this blue curve is the curve x times y is equal to 1. And we want the integral below x times y is less than or equal to 1. Sorry, we want the region x times y is less than or equal to 1, which is the area below this curve and inside the square. So this area right here. And just like we've been doing, we're going to do it in both orders. We'll do it with the x integral on the inside and then the y integral on the inside. But there's a hitch in this problem, as we'll see. So if the x integral is on the inside, that means for every value of y from this point to this point, x will go from the vertical line x is equal to 0 over here. But notice what happens when we get into this portion right here. X no longer goes to the blue line. X goes to the green line. So we have to split this into 2. So for y values from 0 to 1, x is going to go from 0 to 2. Or sorry, that's for y values from 0 to 1/2. X will go from 0 to 2. And we're integrating the function x plus y. Then for y values going from 1/2 to 2, x is going to go from 0 to 1 over y. Now for this first integral, so we have 2 double integrals to do. Just take your time on each one. The antiderivative of x plus y with respect to x is x squared over 2 plus xy, and we're evaluating this from x is equal to 0 to 2, plus the integral from y is equal to 1/2 to 2. And again, the antiderivative is x squared over 2 plus xy. And x goes from 0 to 1 over y. This is the integral y equals 0 to 1/2. So x is equal to 2. So this is, if x is equal to 2, this is 4 over 2, which is 2. 2 plus 2y dy plus the integral y is equal to 1/2 to 2. Okay, now the upper limit is 1 over y. So this is going to be 1 over 2y squared plus 1 dy. This is just a Calc 1 integral, well, 2 Calc 1 integrals, and the answer is 35.75. Now let's quickly do it with the x integral on the inside. So if the x integral is on, or sorry, with the y integral on the inside. So if the y integral is on the inside, we're going to have to split it up similarly. So for x values going from 0 to 1/2, y will go from 0 to 2. And then after that, y will go from 0 to 1 over x. So for x values going from 0 to 1/2, y goes from 0 to 2. X goes from 0 to 1/2. X plus y dy dx. And then for x values going from 1/2 to 2, y values go from 0 to 1 over x. And I'll let you do this, and you'll see that the answer is 35.75. Another way to do this would be to compute the integral over the whole rectangle, compute it over this region here, and subtract that from the integral over the whole rectangle, and that'll give you the integral of this region here. And I'll let you do that to verify that you get the right answer.